Hello everybody, welcome back to another video. In this video we're going to be going over the Rydberg equation, how to solve problems like this. So let's begin. Uh, Starting in the ground state of N1 is a hydrogen atom. An electron is excited to a higher energy level by absorption of 121.6 nanometers of light. What is the final energy state of the electron? Okay, so let's begin. So this is the formula that we're going to be using. It's 1 over lambda, where lambda is wavelength. The Rydberg constant, in this case, we have 1.097 times 10 to the 7 in meters inverse. 1 over n1 squared minus 1 over n2 squared, where n2 is greater than n1. Okay, so the first thing we're going to do is identify we have everything. So we have the wavelength, correct. We have the starting of N1, correct. So we're trying to find, oh, and we have the constant. Check. So it says, what is the final energy? Final energy. So we need to find where is this going to end? Okay, so right off the bat, you need to read this question again because it's going to help you, because that way we can decide where to put 1, because 1 can be either N2 or N1. So if you read the question, it says we're starting. That's the first hint. Another thing is this. According to this, N2 should be greater than N1. This typically the series usually goes from 1 and it goes up. So 2, 3, 4, etc. We can't really have a negative here. So right off the bat, just by seeing that it says N1, and we know that N1 should be smaller than N2, or N2 should be greater than N1. Uh, you cannot put N1 here because you can go lower than 1, if that makes sense. You can go lower than 1, so N1 must be 1. Hope that makes sense. If not, then I know some of you know this formula, and you say, hey, why can't I put 1 in I, correct? This is the initial, if we're starting there. Well, yeah, you're right, but based on this, we can't go lower than 1, if that makes sense. And so if we know this is the lowest, something has to be greater than this number. Another way to see it is, for example, you see here final minus initial. In this case, we're starting here. This is an example. We're starting here and we're going somewhere. So we want to find the final. So from our point of view, we're moving this way. But let's say if you ended here and you want to know where you started, your point of view would be, okay, so let's get the difference of where I started to where yes, from where I ended to where I started. So this is the F, this is the I, and the difference is always F minus initial. That's why this is F minus initial, but in this case, we're starting here. So we want to know how much we moved over here, not how much we're going from, if that's another way you want to see it. But if you don't want to get messed up, just know that n2 is always greater than n1. So, and the lowest you can go is 1. So that's why we pick 1 should be n1. So this is it. Now we plug in everything. So 1 over 121.6. This is nanometer, so 10 to the minus 9 is equal to, I'm gonna just leave RH, but because we know that this is this number, 1.097. So 1 over 1, remember, n equals n1 equals 1 minus 1 over n2 squared. Okay, so type in your calculator this number, how you see it here. I know some of you are not allowed to use graphing calculators during the test, so try to give this a try. So I just type in 1 over 121.6 e over -9. I just write the whole number so you guys can see. I got 8, 2, 2, 3, 6, 8, 4.211. I'm just showing the whole steps so you can practice with your calculator as well. This is squared. RH equals 1 over 1 squared minus 1 over n2 squared. If you have a calculator, I have a TI-30. I store these. There's like a store option. You should know how to use the store button. It really helps. So I just stored this number. Okay, then what I do next, what we should do is divide the RH. So it's 8223684.211 divided by 1. The Rydberg constant, so it's 1.097373 e to the e to the 7. So I got, let me change color. So from this, I got my calculator. Let me get rid of this. Hold on. There we go. I got 0.7493 is equal to 1 squared minus 1 over n2 squared. So we know right off the bat this is just 1. So because 1 squared is 1, 1 over 1 is 1. So 1 over n squared is equal to 0.74939. We just both ways you can do it. This is how I'm going to do it. This is just algebra at this point, but subtract this, move it over here. So that would be 0.74 minus 1. So we move this over here. We get 4939 minus 1 is equal to negative 0.25060. Make some room here. You guys can see this. I think you should have this in your calculator if you're following along. So that means that we are left with n2 squared by itself. So, and here's the thing. There you go. I forgot about that. Negative. Because remember, we just moved this over here, but we still have this negative here. So that's why I put the negative there. So get rid of the negative. -1, -1. That just translates to 0.5 0.0060 is equal to 1 over n2 squared. How can I get n2 squared on the numerator? We inverse this. So, in calculator, you can type in that whole number that you have. So 0. Oh, here's the thing. If you're using a calculator too, make sure to use parentheses. So parentheses 0.25060 parentheses. And then there's an inverse function in your calculator. If not, I'll show you right now. Hold on. So after you got that, I got the inverse of 3.99 is equal to n2 squared. If you want to do it another way, what you can do as well is just do this 0.25060 over 1. This number, if you type that in a calculator, you should get this as well. And since we did the inverse of this should just do, it should be that. That's why this is like that on this side of the equation. And now this is the most easy part. What you gotta do here, take the square root. This is close to 4, so just right off the bat, you can just know that this 4, that's just 2. It's 2. So this is your final answer. So again, take a look, watch the video again if you can, and you can use the explanation I showed you. If not, just always go off this principle here. This is very important because sometimes you need to find the wavelength. So they're going to give you, let's say, they say ending and n equals 2. And let's say starting in 1. So 1 is less than 2. So this goes here, and that goes there. Or vice versa. If it says this is initial and this is final, just take a look at the example I gave in the beginning of the video, and these problems should be easier to you. I will upload another example of this. In the next video, I will be showing how to get the wavelength when you have these values, when you have N1 and N2. And that's it for this video. It's a short video. Thanks for watching.